Welcome to my channel.
Hello, today we're going to talk about exponents and radicals. So what's exponent? When a number is being multiplied by itself, then you can write it in the form of exponent. For example, if 2 is multiplied with itself 2 times, then you can write it as 2 to the power 2, and that's also called square of 2. Then if you have 2 being multiplied with itself 3 times, then you can write it as 2 to the power of 3. It means you have so you're gonna write it as 2 to the power of 3 or cube of 2. Okay, 2 cube. Now that's about exponent, where simply number is being multiplied with itself, and you can write that in simply as an exponent, as in power. Now what's roots? So root is just like you are trying to find out a number. For example, if we have 27 or we have 4, for example. So if we want to find a root of 4, so we are going to try to look whether this number 4 can be written as some number which is being multiplied by itself or not. Okay, for example, we do know that 4 can be written as 2 times 2, means 4 is simply the square of 2. So here this 4 can be written as a product of 2 with itself 2 times, so it's simply the root of 2. But roots are not of one type, like their roots have different power, just like the exponents are 2, 3, 4. It depends upon if we are increasing the number of times the number is multiplied by itself, then our power will also increase. Similarly here in the radicals, if we are talking about a number which is being multiplied with itself 2 times, then that number will be called the square root. But for example, if we have 27, we do know that 27 can be written as a product of 3 times. So 3 times 9, and 9 3 times is 27. So it means that this number 27 can be written as a cube of 3. So this 3 is the root of 27, but not simply the root, but it's the cube root. So when we're gonna have the roots, we are supposed to discuss the powers as well, which we are having the root of which order. Okay, just like the exponents of 2, 3, 4, like this. Now if we're going to go in somehow complex, the roots are going to be represented by radical sign. This sign is called the radical sign, and because of because this is called radical sign, and whatever we're going to write inside, that is going to be called the radicand. So this is called radicand, and whatever we are going to take the radical of whatever order, that power will be written here. If it's a order of 2, then you're gonna write 2 here. If it's an order of 3, you're gonna write here 3. Otherwise, whatever the order it is, it will be called index. A number when raised to the power n gives us the answer b. Okay, that simply you would say the exponent. We have taken the exponent of a, and you got the b. A to the power n means we multiplied a n times and we got the answer b. Now we want to find the root. So how we're gonna root is gonna be introduced here. For example, we want to find a. We want to check what's a. So what we'll do, in the power we'll introduce a fractional exponent which is 1 over n, and if we are doing something on one side of the equation, we are supposed to do some similar thing on the other side. This n and n gets cancelled because numerator and denominator, so we'll get a equals to b to the power 1 by n. It means the thing we were talking about earlier, the radicals or the roots, where roots is just like finding the number with the number which is being multiplied with itself number of times to get that number. So to get that thing, we can we did this thing to get this number a. We introduced 1 over n. We got that a equals to b to the power 1 over n. That is simply a way to write the radicals or root in the form of an exponent. So radicals or roots are also the exponents, but these are called the fractional exponents, where you're gonna have 1 in the numerator, and in whatever you're gonna have and in the denominator, that will tell you the order of the root. So one thing, keep it in your mind that n is going to be greater than 1. It cannot be equals to 1, because if it's going to be 1, for example a equals to b to the power 1 over 1, then it's not the exponent. Okay, then it's not the fractional exponent. so it must be 2. For example, a equals to b to the power 1 over 2. So it's showing us the second root, this which is called also square root. And to write this, we're gonna write the radical sign, which for example 2, and we can write it as b, square root of b. And if you do not want to write this 2, don't write it, because that's actually the starting, the very first root. So you can, if you want to skip this, you can skip this. Otherwise, the other way to do this is, for example, if we have b raised to the power 1 over 3, that will be simply cube root of b. Hope so this is clear till now. What are powers, what are exponents, and what are roots, so radicals. So exponents and radicals are actually the similar thing, where exponents are simply the exponents. It can be the fractional exponents, but radicals are very specific exponents, where you're gonna be having the exponent, fractional exponent, where your numerator is going to be 1 and denominator is going to be whatever the order of the radical you want to choose. And keep it in your mind, whenever you're finding the radicals or root, it's just like you're trying to find a number that is being multiplied with itself to get that number. So if it's a square root, that number will be multiplied with itself 2 times. If it's a cube root, that number will be multiplied with itself 3 times. Hope so this basic concept is clear. Now we're gonna move towards the question 3 of exercise 1.2. This question is saying, write each exponential expression as an equivalent radical expression. We are supposed to write these ones in the radical expressions. We have first 216 raised to the power 2 over 3. So now it's 2 over 3. Now 2 over 3 is a fraction. When you're gonna have a fraction, we can actually split that fraction into 2 parts. For example, we can write 216, and we can write 2 inside and 1/3 outside of this fraction. Because how we can write like this, look, if we have 2 over 3, that's simply 2 times 1 over 3. That's simply 2 times 1 over 3, because that will also give you 2 over 3. So what we did is we just splitted this thing into, the numerator will be written inside, and the denominator with the exponent 1 will be written outside. Why we did this? If you're gonna look at this, that is going to give you that 1 over 3, where your numerator is 1 and denominator is 3. It's giving you the cube root, so it's the cube root of 216 square. So that is simply the radical expression of this exponent form. And if we want to solve it further, we do know that the 216 can be written as 6 cube, because 6 being multiplied with itself 3 times gives us 216. But right now, if you do look outside we have the cube root, and so it means if we have the cube root is simply 1 over 3, and whatever the power we have inside, that should be something 3 or the multiples of 3, so that it can be cancelled. So what we're going to do, we're just going to interchange these powers. We're gonna just interchange. 2 will be written inside and 3 will be written outside. Okay, we do study the properties of radicals, where we do know that we can change these powers, or you can consider this as 2 times 3 or 3 times 2. It's the similar thing, so that's why we just interchange these things, and you can consider the commutativity. Then this cube will be cancelled with this cube root. And how do we cancel this? Because you know cube root is the fraction exponent. We're having the 3 in the denominator, and this exponent is 3 in the numerator, so these two get cancelled, and 6 square will be equals to 36. Then we have, if we're gonna look at this other part, where 216 raised to the power negative 2/3. So now 216 raised to the power negative 2 over 3, we're gonna do the first thing as it is, like we're gonna just split this fractional exponent into 2 parts, where the numerator will be written simply out inside, and denominator with the numerator as 1 written outside, like this. Here we can write it as the cube root of 216 to the power minus 2, but we do know that 216 has a power negative, and what we're going to do, we're going to make this power, you can say this is the exponent form, and if we want we can solve it further. We do know that this this 216 has the negative power. So to make it positive, every time when you are going to have a negative exponent, you can make it positive by simply moving it. If it's in the numerator, move it in the denominator, and if it's in the denominator, move it in the numerator. That's it. So that's 216 to the power 2. Now that's simply the exponent form of this number 216 raised to the power minus 2 over 3. Or if we want, we can have the other way to write this number directly. That is that this is 216 has the negative power, so we can write it as 1 over 216 to the power positive 2 over 3. So what we did, we just moved our number which is having the exponent in the denominator. We just flipped this, so we got the positive power. And after this you do know very careful, you do know that this 3 is representing, this is cube root, and the power we have written in the numerator, that's representing the square. So that's simply 216 square are the thing you got here. And here you do know that the root will be split over the numerator and the denominator, so cube root will be over the first number, the numerator, and the denominator. Cube root of 1 or square root of 1, whatever you're taking the root of 1, whatever the root or the power of 1, it's always going to be 1. And we solve 216 to the power 3 just right now, so we are just going to write that answer which is 36. Hope so this part is clear. Now we're going to talk about this question number 2, which is 29 raised to the power 1 over 2, where from looking at the power you come to know that's a fraction exponent, where your numerator is 1 and denominator is 2. So it's representing the root, so it's the square root of 29, and which cannot be solved further. So that's the answer. Then we have question 1 over 32 raised to the power 1 over 5. So 1 over 32 raised to the power 1 over 5, to write this in the form of exponent, radical, what we're going to do, we do know numerator has 1 but denominator has 5. It means it's the fifth root, so we can write it as fifth root of 1 over 32. So that's the radical form of this expression. Now if to solve this further, we do know to find the cube root means we're trying to write that number. First we're going to do is split this fifth root over the numerator and the denominator as well. And finding the cube root means you are trying to look for the number which is being multiplied with itself 5 times to give you 1, and you do know that is simply 1. Or if you are, because you know when 1 is multiplied 5 times with itself, it will also give you 1. So we can write this 5 as 1 as 1 times of 5. So cube root and this get cancelled, and for 32, that this 32 can be written as 2 to the power 5. And how do we know that this 32 can be written as a power of 5? We're gonna just look for the LCM, and we came to know that 2 1 times 2, 2 6 times 12, because here 1 carry. This is the bus stop method. 2 8 times 16, 2 9 times 2 4 times 8, 2 2 times 4, and 2 1 times 2. It means we can write 32 as a in terms of multiplication of 2 multiplied with itself 5 times, and you don't know cube, this power will be get cancelled with this one, and we'll be left with 1 over 2, the simplified form. Then we have the question 1000 raised to the power 1 over 3. 1000 raised to the power 1 over 3 is simply, we want to write 1000 as it will be written in the radical form as 1000 raised to the power 1000 under the cube root. Now if you want to find the cube root, it means you're looking for a number which is being multiplied with itself 3 times to get this 1000, and that number is 10, because we do know that 10 times 10 is 100, and 100 10 times is 1000. So it's simply 10 times is 100, and 100 10 times is 1000. So we can write it as 10 to the power 3, and we do know that root is something in the denominator, and this is simply the numerator gets cancelled, and we are left with the answer simple 10. We had the last question with question number 6, 1 over 36 raised to the power 1 over 2. So we have 1 over 39 which is being raised to the power 1 over 2. And to write it in the radical form, which is very easy, what we are going to do, we are going to just write it under the root, because 1 over 2 is just telling us that this is the square root, because in the denominator we have 2, which is representing order of 2. So that's simply the radical form. And if we want to solve it further, what we can do, we can split the radical or the root over the numerator and the denominator as well. And the root of 1, whatever the root of 1, it will be always 1. Why? Because right now we are finding the square root of 1, means we're trying to look for the number which will be multiplied with itself 2 times to get this 1, and that number is 1, because 1 square is simply 1. 1 times is 1. And but square root of 39 is not possible, because there is no such number which is being multiplied with itself to get 39, to give 39. So this square will be get cancelled with this square root, and this will be 1 over 39. There is a quick takeaway that whenever you are taking the square root, cube root, or whatever the root of 1, that's always going to be 1, and just keep it in your mind. Okay, and now we're gonna discuss exercise 1.2, question number 3, which is write each radical expression as an equivalent exponential expression and simplify if possible. So we have our okay, the first question, cube root of 5 and the whole thing in the square. So cube root of 5, you know that when you have the cube root of something, that cube root is simply 1 over whatever the order. If it's the cube root, it's made it's 1 over 3, and this whole thing is raised to the power 2. And we do know the rule of indices, when you have two exponents, one inside the bracket and one outside the bracket, those are going to be multiplied and it will become 5 raised to the power 2 over 3. So that is simply the exponential expression, and it cannot be simplified further. Now the question number 2. Now question number 2, which is 4th root of 10 and that whole thing under the power 8. So we do know that 4th root is simply 1 over 4, because for what is root or radical, it means simply it's the exponential form where numerator is 1 and denominator is whatever the order, and then this whole thing raised to the power 8. And as we do know, when you have two powers, one inside, one outside, they are both going to be multiplied. So this 8 will be multiplied with 1. 1 times 8 divided by 4. So that is simply the exponential form. And if we do want, we can simplify. This is the exponential form. And if we want, we can solve it further. And how we can solve? We do know that this exponent, this which is 8 by 4, this can be simplified. This exponent 8 by 4, it can be simplified. How? Because we do know they both have the similar factor, which is 4. So 4 1 times is 4 and 4 2 times is 8. So we did the cancellation and we left with 10 raised to the power 2. 10 raised to the power 2 means 10 will be multiplied with itself 2 times to give you the answer, and 10 will be multiplied with itself 10 times will be 100. So that is the final simplified answer. So it has two answers right now. The first one I've told you, that is the exponential form, and this one is the simplified form. After this, now we have question number 3, which is minus outside and cube root of 6, the whole thing inside. This whole thing is raised to the power of 6. So we do know what we're going to do inside. Cube root of 6 is simply 6 to the power 1 over 3, because cube root itself just the fractional exponent, where whatever the order of the root, whatever the order of the radical, that will be written in the denominator, and 6 as there was the exponent outside. And as we do know, when we have powers inside and outside, both are going to be multiplied. So this will be 6 1 times 6 and 6 over 3. And as you can simplify the exponent further, how? We do know that 3 and 6 have the common factor, which is 3. They both can be divided by 3. So 3 1 times is 3 and 3 2 times is 6. So this will be minus 6 raised to the power 2. And 6 to the power 2 means you're going to multiply 6 with itself 2 times. So it will be minus 6. It will be simply 6 times 6, not minus 6 times minus 6. Why? Because this is a square of 6, not minus 6. So this will become minus 36. So this is the this is the, you can say this is exponential form, or if you want, this is exponential form if you without cutting, and the other one, the simplified answer is this one. Now there is, if you look at this question number 5, that is similar to this question number 1. So let me tell you how to do this. This is simply minus cube root of 5 and the whole thing raised to the power 2. So this is simply, both of them are similar, but what's the difference? That the difference is just of sign. So it will be, minus will be remain outside and 5 will raise to the power 2 over 3. Why 2 over 3? It's very clear. 2 is the power and 3 is the root, order of the root, which will be written in the denominator. Here there is question number 4, which is similar to this question number 2, but the difference is that there is minus outside this expression. So what will be the difference? That is quite easy. The difference is simply of the minus sign. So minus 4th root of square root 10 raised to the power 8. So this whole thing will be similar 100, but with the negative sign. So this is the similar answer with this, just like this question, but just the negative sign, because there was a negative outside. I can indicate this, like there is a negative like this, like this, like this, like this. So it will be similar, but the negative is showing if there will be minus, then how it's going to behave. Then it will be just minus outside this. Then we have this question. We solved this question with the negative, and now we have a similar question with the positive. So what is going to happen? Nothing is going to happen. I'm using a different color. This minus will get changed with the plus, 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 and plus. That's it. Everywhere where it was minus, that is going to be just changed with the plus. Otherwise the rest of all other things are similar.